The question reads, the transformation t from the z plane to the w plane is given by t of z is equal to I bracket open. So note that we've already seen that I square is equal to what? -1. So this I is used to represent the square root of -1, because we cannot deal with -1, the square root of -1, so we just represented it by this number I, so that whenever you see I square, it means that it's just the square of this. So the square will deal with the what? The root, leaving the -1. So I square is equal to what? -1. So in complex numbers, you'll be seeing this imaginary number. So this I is for what? An imaginary number used to represent what? A negative roots. And the basic negative root is -1. So it is used to represent the what? The basic negative root, which is what? -1. So that is it for the explanation to I. So t of z is equal to what? I bracket open z plus 1 all over z minus 1. So we have two planes. We have what? The z plane. So let's say this is the z plane, and a transformation. So there's which transform the z plane to what? W plane. So we have, this is the real axis, so real axis, so real part of W, real part of Z, and this is the imaginary axis, so imaginary part of what? Imaginary part of Z, imaginary part of W. So this is how the transformation has occurred. Maybe it is something here, let's say a rectangle or a square, but here it has been when after transforming it, after applying this transformation, it becomes like, let's say, a circle here. So that is just what the transformation is all about. So let's continue with the question. Where z is a complex number and z is not equal to 1, so z is not equal to 1, find and sketch the locus of w as z moves on the circle. The magnitude or the modulus of z is equal to what? 1. It moves on a circle of radius 1. Okay. So let's quickly look at this problem. So let me copy this. It's here, and remember that this transformation, so the transformation from what? Z plane to W plane. So after applying this transformation is W. So it is safe to say that t of z, after transforming z, will get what? W. So I won't be writing much of t of z. I will be writing W. Okay. So and we've also been given this is on moving on the circle. The magnitude of z is equal to what? 1. So let's see how we will deal with this. So we know that w is equal to I multiplying z plus 1 all over z minus 1. So we can multiply through by what? Z minus 1. So we have what? wz minus w is equal to I z plus I. So WZ, we can group the Z's and make maybe W the subject, but let's just group the Z's. WZ minus IZ is equal to I plus W. So we can factor out the Z's, and we have Z bracket W minus I is equal to I plus W. So by taking magnitude or modulus of both sides, we have that the modulus or magnitude of Z, we've been given this guy, so we are trying to make sure that we see this, we see the the magnitude of Z, and wherever we see it, we can replace it by the one we've been given. Okay, so Z multiplying W minus 1 minus I is equal to the modulus of what? I plus W. But we know that, let me just cancel the but part. We know that this is the same as what? The modulus of Z, or the magnitude of Z, multiplying the magnitude of 1 W minus I is equal to the modulus of I plus W. But this guy, W is Z, magnitude of Z is equal to 1, and let the complex number W is equal to, let's say, X plus IY. So here we'll have 1 multiplying the magnitude of X plus IY minus I is equal to the magnitude of I plus W, our W is now X plus IY. Know that complex numbers, so let me pause here and then explain this. Complex numbers, let's say, usually we represent it by Z or W, is written as what? Maybe A plus IB, and they are also seen as vectors, so the magnitude of Z here is equal to the root of whatever we have there, A square plus B square. This is actually seen as a vector. In vector form, we have Z, the vector form of it will be A, B, or A, comma B. So this can be written in vector form, and the magnitude or modulus is what? A square plus B square. So here we also, and where A is what? Where is the real part? So A is a real number, and the real number is called the real part of what? The complex number. And the one with the imaginary number I is the imaginary part. So B is the imaginary part of the complex number, and A is the what? The real part of the complex number. So the modulus or the magnitude of the complex number is what? The real part square plus what? Square root of the real part square plus what? Square root of the imaginary part. So here let's group what we have here into what? The imaginary and the real part. So we have the magnitude of X plus, so our I multiplying Y minus 1 should be equal to the magnitude of x plus I multiplying y plus 1 or 1 plus y. So magnitude of that, and this will, so here the magnitude of this is just what, the square root of what, the square root of x squared plus what, the imaginary part y minus 1 square, which is equal to what, the square root of x squared plus the imaginary part, which is y plus 1 square. So this will lead us to, if we square both sides, both has the square root, so if we square both sides, we have x squared plus, let's just simplify this, y minus 1. If we are simplifying, we will take this y, the easy way, we square y, so we have y squared minus 2 times y, so 2 times y times 1, 2 times y times 1, so minus 2y plus 1 square, which is 1, to the other part too, we have x squared plus y squared plus 2y plus 1. So let's group all terms. So let's group like all the distance. We are grouping all terms containing variables to the left. So here we just have x squared. If we bring this other x squared to be 0, so this x squared and the x squared here will cancel out. Here we have y squared. If we bring this y squared to it, will what, cancel out. We have minus 2y. Let me have 1 minus 1. So here we only have 1 remaining. So if I bring this one to be 1 minus 1 is equal to what? I have 2y here. If I bring the negative 2y to this side, we have plus 2y. So I have 1 minus 1, which is 0, is equal to 4y. So you can divide both sides by 4, here by 4, and you see that therefore our y is equal to what? 0. So after performing the operation, after performing the transformation on z, we see that we have y is equal to 0, and that is the x-axis is the line y is equal to 0. So let's check what we've been asked to do. Let's check what we've been asked to do. So let me open the question. Let me close this for the meantime. Okay, so find and sketch the locus of W as Z moves on the circle. Okay, so we found that W is what? W is now the line y is equal to 0. W is now the line y is equal to 0. So let me clean everything, leaving y is equal to 0, and we sketch it. Delete all, and then now we know that we have y is equal to 0 will now be in what? The W plane. Y is equal to 0 will now be in the W plane. So, and if we are sketching it, we have our real part of what? W, or imaginary part of W, and this is the line y is equal to what? 0. That's what the x-axis. So So the locus is what? The line. So the locus is the line y is equal to 0, comma, that is the x-axis. So if we transform the circle with radius 1 given, so let me close this and explain. If we transform the locus, if we transform the circle with, so the circle with radius 1, if we transform it using this transformation, we will come to the conclusion that W, in the W plane, this circle with radius 1 will become a line, and that line is what? The line y is equal to 0. That is what? The x-axis. And that's what we've done. Please, if you don't understand anything, let me know in the comment section, so that I'll see how best I can help you with maybe new or different approaches to fit your level of understanding. Thank you very much for your time and attention. Have a wonderful time. I'll leave my channel link in the description, so that you can follow me on WhatsApp. You can even chat me directly for your problems. Thank you once again.